All right, so point slope form is the equation of a line in point slope form where you have y minus y1 equals n x minus x1, where y1 and x1 are coming from a point on your graph, and m is still your slope. So now you have point slope form, so you add another equation to that list. So point slope form is where we're given a point and our slope. So it's y minus y1 equals our slope, x minus x1. So your point is x1, y1, and our slope is always m. So m is always slope all of the time. And our point is the x1, y1. If you're given 2 points, like with slope, then you can calculate your slope and then pick either point and plug it into point slope to get an equation. We're going to see examples like that today as well. So in this first 2 sets of examples, we are given a slope and a point. So in those first 2 sets of examples, you're given a slope and a point. So what we're going to do is plug in to point slope form. So this is x1, y1. This is my m. So it's y minus y1 equals m x minus x1. So minus a minus turns to a positive. To get this in standard form, we have to get the x's and y's on the same side. So we're going to distribute the 3. So I have y minus 5 equals 3x plus 3. So I'm going to subtract the 3 from both sides, as well as the y. And then I'm going to use the property of reflection to say 3x minus y equals negative 8. Because over this way, it's like negative 8 equals 3x minus y. But to be in standard form, you need ax plus by to be on the left. So my standard form is 3x minus y equals negative 8. In example number 6, my slope is 2, and my point is x1 being 4, and y1 is negative 2. So I'm going to plug into my equation. So it's y minus y1 equals my slope, x minus x1. We're going to simplify the minus a minus and turn it to a positive, as well as distribute the 2. And then we're going to get x and y's on one side and numbers on the other. Bye guys, you're welcome. So you get 10 equals 2x minus y. And again, to be in standard form, we're just going to use the reflexive property to say 2x minus y equals 10. number 7, plug in your slope, plug in your point. So you have y minus 6 equals 5, 6, x minus 5, or y minus 6 equals 5 over 6, x minus 25 over 6. And we know in standard form we cannot have a fraction. So what we're going to do is multiply everything by 6. And that will get rid of the fraction on the right. So you get 6y minus 36 equals 5x minus 25. And then that becomes 5x minus 6y, because we're going to subtract 6y to the other side. And then you're going to add 25 to the other side. So negative 36 plus 25 gives negative 11. Now 8 is a little trickier. In example number 8, I am not given my slope. I'm given 2 points. So if you're given 2 points, but not a slope, we have to use our equation of slope to find the slope. So that's y2, which is negative 1, minus y1, which is negative 3, over x2, which is 5, minus x1, which is 4. And you get 3 minus 1, which is 2, over 5 minus 4, which is 1. So now I have my point and my slope. So I'll plug in my y1, which is negative 3, my slope, which is 2, and my x1, which is 4. And then we have to get our x's and y's on the same side. So you'll subtract y and add 8. Yes. Okay. Right in slope intercept form. So slope intercept is y equals mx plus b. So really following the directions is a big part of this, because the previous ones were standard. This one is slope intercept. We're given 2 points, which means I need to use my slope formula again. So we'll label x1, y1, x2, y2. So you get 2 minus 0 over -3 minus 5, or 2 over -8, which you can reduce to -1/4. Either is fine. So if you leave it here, that's fine. If you simplify, that's fine. Now, in the case of this problem, you're not given the y-intercept. So a lot of the problems over the weekend, we were given the y-intercept. In this problem, we're given the x-intercept, but that doesn't help me. So what we have to do now is use point-slope form and simplify. So we're going to use the y minus y1. So in this case, my y1 was 0, equals my slope, which is -1/4, x minus x1, which was 5. Now, I used the point 50. This would also work if you used the point 2 and -3. So your slope didn't change, but you could have used y2 and x1, and it would still simplify to the same answer. Using x1 and y1, we get y equals -1/4 x. Negative times a negative is a positive 5/4. Good? And then in 10, same idea. Find your slope using x1 and y1, x2 and y2. So 17 minus a -1 over -10 minus a -2. Again, double negatives turn to positives, and you need to make sure when you stack them, y2 is always over x2, and y1 and x1 are always matched or stacked as well. So 17 plus 1 is 18. -10 plus 2 is -8. Both divide by 2, and you get 9 over -4. Pick either point to plug in. And it's y minus a -1 equals -9 over 4, x minus a -2, or y plus 1 equals -9/4 x. This is plus 2, so times the negative is -18 over 4. And then you have to subtract 1 from that. So you get y equals -9 over 4x. And something else I noticed, make sure you understand that x is in the numerator. And -18 over 4 minus a 1, you can either write as -22/4, or it's -9/4 x minus 11 halves. Yes. Yeah, because 18 and 4 both divide by 2. So yes. Yep. I just, because I was multiplying without a calculator, didn't reduce it. But you're good. Okay, so hopefully today again is one of those lessons you're like, yeah, that wasn't terrible at all. Your homework's that next page in the packet. So we actually already did 1 and 2, so you're doing 3, 4, and then 12, because we did 8, 9, 10, and 11. So you're doing 3, 4, and 12 to 22. At a point in time, I used to do that all in one day, but realized it was just too much.